Assalamu alaikum everyone. Hello and welcome. I hope everyone is doing fine. So today we are going to learn about some basic arithmetic functions done in assembly language. So this lab, actually lab 2, is about performing some basic arithmetic functions such as subtraction, addition, multiplication, divisions, etc. using assembly language. In assembly language, as you all know, we are already using RISC programming instead of microprocessor 8086 programming. So we are going to continue with that, as many of the students have missed the lab 1, and also the section A students, they did not actually participate, they did not actually understood the simulator that we are going to use. The simulator that we are going to use, this is for everyone, as we are doing RISC programming. So we are going to use Mars. So section B and section C students already know about the Mars, but I am again going to elaborate about this simulator Mars, MARS version 4.5. So this is the simulator actually that we are going to use for our RISC programming, microprocessor and assembly language course for the labs. This simulator is actually available free of cost online. So you simply go to the Google and simply write down Mars simulator as written here. So the first link that will open Mars map simulator, when you click it, this website will open. Simply go to the downloads, and when you click on downloads, the download link will be given below. Simply download it here, click it, and you will see Mars 4 underscore 5 will start downloading, but as I have already downloaded it, so I do not need to download it. So when you will download this file, it's free of cost, and it's a jar file. It will need you to upgrade your Java version to Java 9 because it runs on Java platform. So you will just download it, and it will be no need to install. You will just double click it and it will run. So it is shareable via USB also. You can share it with other friends also. So when you double click it, this screen will open something like, let's say I will open it again. So I have it here. Let me just find it where I have placed it. So when you download the Mars simulator, Mars will be downloaded somewhere in your folder. So here it is, my Mars. When I double click it, so this screen will open in front of you. So it has actually three sections, just like every other simulator you use for your programming. Like you use IDEs such as Notepad, such Notepad plus plus. You use code blocks, Dev C plus plus. They all have different sections, right? So similarly, Mars is a simulator based for assembly language, and this is specialized for RISC programming assembly language, or ISK, RISC programming. This ID also has three sections, similar sections such as code blocks. This section, as you can see in sky blue color, this is editor. This section right here under, this is message section. Here is a new section that you are going to find. These are all register sections, because in assembly language we use registers for variables and all the data manipulation. So we get to see what's happening at the hardware level. So this is all the register sections. So actually there are 35 registers you can count here. First one is $0. So dollar is actually a symbol to nominate for registers. So $0, first register. This is fixed register for constant value of 0. So whenever you need to use the value 0 in your assembly language, you're going to use, instead of initializing 0, you're going to use $0 because they have fixed it for the assembly language. So then second number register is $80. Leave it, no need to know about that. This is reserved for assembler. Next is V0, V1. These two are used for actually the return value when such as in C++ you use functions, and at the last line of the function you return some values. So if you're going to use functions in assembly language, you're going to use V0 and V1 for the returning values. Same goes for A0, A1, A2 and A3. These four registers are used for arguments values used in functions, such as in C++, you use functions, and for functions, you use arguments. So if you're going to use functions and you're going to give them arguments, you're going to use these four registers A0, A1, A2, A3, and uh, these four A0, A1, A2, and A3. Next are the registers for general purposes. For example, you want to use some variables, you want to store some values, you want to take some values as an input, you want to give some value as an output. So you're going to use these registers starting from T0 to T7. Then come here, you will see T8 and T9 also. So temporary registers are total 10 registers, T0 to T9. In between them, you will see S0 to S7, these 8 registers also. So they are also used for temporary purposes. A slight difference, temporary are only used inside the program, these T0 to T10, T9 actually. But these S0 to S7 registers, they can be used everywhere. So most probably we are going to use S0 to S7 just like our variables. Next we come, so we get to see K0 and K1 registers. They are reserved for kernel, operating system kernels. We cannot use them. Similarly, we cannot use these. These are actually pointers. GP means global area pointers. SP means stack pointer. FP mean frame or file pointer. RA mean return address. So I don't think that we are going to use these all registers. PC, high, low, FP, GP, RA. These all registers we are not going to use in our this semester actually. So forget about them. So now in today's lab actually we are going in lab one. We did a hello world program actually, but today we are going to use some basic arithmetic functions in assembly language such as addition, subtraction, multiplication, and division. I am going to write a code that adds and subtracts two numbers in assembly language using RISC programming, and I have also added that in your file also. Your task will be, let me just open the file. uh, Sorry. Yeah, so task one I will be doing, I am going to write this code in Mars and going to run it, then your task will be, this task is actually going doing addition and subtraction, so I will be doing addition and subtraction for you. So you will be doing in task 2 and task 3 multiplication and division. So let's start with the task 1. Is this goes from here to here. So I am actually, I have written this code right here, so I am going to open it from Mars. So Mars, I will elaborate one by one also. File, open, lab2.asm. So this code I have written it already here. So this is actually your coding section. You are going to write your assembly language code in this area. So whenever you have written the code, you know you have written the code, just save it. File, save as, or save. So because I have already saved this program, so I am not going to resave it. So your first step will be to save it. Whenever you are going to save the program, this option here will become active. So this option is actually for assembling your code. So you're going to click on it and your program will assemble. So now if I click it, so my program assembles without any error. So if you have some error, your errors will be shown here, and this table like form will not appear in front of your eyes. So because my program does not contain any errors, so I'm going to go back to my code. So this is actually the code. I'm starting from dot text dot global main, uh, just like formal activities you use in C++ and C programming. So text section, what I am doing in main is actually I am taking three numbers, 10, 20 and minus 30. For taking three numbers, it's just not like what we already use in C++ or C programming. I am going to use these mnemonics. Add I means add immediate. What I am going to do is I am ordering assembler that add this value 10 plus 0. I have not written here 0. If I write 0 here, the decimal value of 0, this will generate an error because assembler has already fixed a value for 0, that is $0, this register right here. So to get the value in assembly language, that means to store the value of 10 in assembly language in a register, you will use this command add I. What I am doing here, add I means add immediate. I am adding 10 plus 0 and I am storing it in S0. So first argument is always for the register where you want to store the value. Of which value you want to store, they are used in second and third arguments. What arguments I have given the instruction that add. So add this value plus this value and store in this value. So I am adding 10 to 0 and I am storing it in S0. Similarly, I am adding 20 plus 0 and I am adding it in S1. Similarly, I am adding in minus 30 plus 0. I am storing it in S2. So actually this will store 10 in S0, store 20 in S1 and store minus 30 in S2 registers. Next up, I am going to add these numbers one by one. So here you see add T0, $T0, $S0, $S1. So this one, I'm ordering my assembler to add S0 and S1 values. What is in S0? We already know it's 10. What is in S1? We already know it's 20. So we are adding 10 and 20 and storing the result in T0. Similarly, here I'm adding S1 and S2 values. So S1 is 20 and S2 is minus 30. I am adding 20 and minus 30 and storing it T1. Similarly, S0 and S2 10 minus 30 addition will be added in stored in T2 registers. Same goes for subtraction. S0 and S1 subtracted and the result in T0. Again S1 and S2 subtracted, result goes in T1. Again S2 and S0 subtracted and result goes in T2. In assembly language, whatever IDE, whatever simulator you are going to use, your teachers, your instructors will always instruct you that you go step by step, because you need to know what values are going to store in your registers. So that's what I am going to recommend you. This simulator also recommends you, every other assembler recommends you that you go step by step. So we are going to do all the tasks, all the instructions step by step, because we need to know whatever values we are giving to the program, they are happening just like we want them. So if you see here, this option is for run. This will, if you click this option, this will just like run, this will run just like your normal compilers. This will execute the whole of the program at once, but we do not want to do that. So we want to do this one, run one by one. So when you assemble it, so this, if you do, your program does not contain any errors, this section will open up, execute section. Here this section contains data segment. If you have any data, that will be displayed here. So your register values are now displayed in decimal numbers. You can also display them in hexadecimal values, which is recommended. So if you click hexadecimal values, they all will appear in hexadecimal values, but for now we will consider it as decimal values. So now if we click on this tab, so you see here this yellow line is clicked. This means that we are going to perform what was written on line number 4, the instruction number 1, that is add I dollar S0 comma dollar 0 comma 10, so that we can come to know what's happening on this line. So if I click on this tab, so you will see I ordered the assembler to add 10 and 0 and store the value in S0. So this section now shows me that in register S0 there is a value of 10 stored. So if I click on the next instruction, I should get S1, I should get 20 value in S1. So now I get 20 in S1. Similarly, minus 30 in S2. So now I have stored all the three values that I want to use in my program: 10, 20 and minus 30. 10 is stored in S0, 20 is stored in S1, minus 30 is stored in S2. These S registers are being used as variables. Now I will perform the calculations, and those calculation performed variables will be stored in T0 and temporary registers. So from this line we are going to perform some basic arithmetic function. First one is addition. We are going to add S0 and S1. What is in S0? 10. What is in S1? 20. So let's perform this. So answer should be in T0. When I click this, so now you see this T0 register is highlighted and the answer is 30, which is correct. Similarly, the next answer, similarly, the next addition, all the three answers have been placed in T0, T1 and T2. Now the subtraction of S0 and S1 goes in T0. Similarly, S1 and S2 goes in T1. Similarly, S0 and S2 goes in T2. All the three subtractions are also rightfully and correctly displayed in T0, T1 and T2 registers. So you can also display the values in hexadecimal values. So you see these hexadecimal values are also displayed even in T0, T1, T2, and also in S0, S1, and S2 also. So convert them back to the decimal values. So this is all. Your program is almost finished. You are done with the last line. So if you click on the next step, your program terminates because all the instructions have been executed. So the message will be displayed, program is finished running. Okay, so this is a simple program that was doing addition and subtraction. I have written this code in your file. Your task will be that you need to copy the same program, and you're going to change the same program. Now you're going to multiply and divide using MUL for multiplication, div for division operation instructions. So task 2 is very much similar and very easy. Task 3 is actually a little bit confusing and a little tricky, because in task 3 you are also again going to multiply and divide the numbers, but but instead of using mul for multiplication and div for division, you are going to use SLL and SRL. Now SLL means shift left and SR means shift right. So shift right means you are dividing a number with the value of 2 raised to power whatever. Shift left means you are going to multiply the number with the value of 2 raised to power whatever you give at the third. So I have given an example SLL T1 T1 3. This means that I am going to multiply a number whatever is in T1, multiply with the 2 raised to power 3, which is 8, and the answer will again be stored in T1. So you are going to use SLL for multiplication and SRL for division. So this is your task 3. So I have given instructions how to send me the email, how to send me the files of these tasks, two tasks that you have performed. But before that, copy this program. These are all comments, but this is actual program. Copy this program, run it, execute it, get to know the Mars simulator when you are comfortable. So then perform these two tasks and email the task at abrar-ahmad@usa.edu.pk. Your deadline is 11:59 of tomorrow. That is 12 o'clock tomorrow. You will until the day the classes are on in the campus. So we are going to use this medium. I'm going to um, send you the lab files, and I'm going to give you a one complete day so that you can perform your task and you can email me back my the task to me, and your attendance will be marked on that, your lab marks will be marked on that. All right, so that's it. Best of luck, and do good, and most importantly, be home, be safe. That's for you. Be home. Okay, best of luck.